Everyone. Today we'll be going over a cool little algebra question. Prove that for all prime p greater than 3, p squared minus 1 is congruent to 0 mod 24. Take a second to pause if you like, and we'll be talking about the solution now. So let's dissect this part first. P squared minus 1, we can rewrite this as p plus 1 and p minus 1. And we can break 24 into 8 times 3. So we know p is odd since it's a prime greater than 3 and 2 is the only even prime. And we know that for all odd numbers, this is congruent to 0 mod 8. Why is this? Right, this is because if you have an odd number, the value to the left and right have to be even. And suppose this is 2 times an odd number. Well then, right, when you go up 2, you have 2 times an odd plus 1, which is an even. Which means if this is only divisible by 2, right, this will give you at least a 4. And 2 times 4 will give you 8. Great, so we've proved this. Now let's prove that p plus 1 times p minus 1 is congruent to 0 mod 3. Now, we know that we aren't divisible by 3 since that would make it not prime. So p has to be something like 7 or 11. It can't be 9. What this means is that, right, if we think of, like, let's say, everything mod 3, right, we can either be 0, 1, or 2. But we can't be 0 because, like we said, then you wouldn't be prime. So our numbers are actually just 1 and 2. Right, and 3 loops back to 0. Well, obviously, right, if we're 1, p minus 1 maps us to 0, and if we're 2, p plus 1 maps us to 0. So no matter which element we are, we'll always be mapped to 0 through p plus 1 and p minus 1. So since both of these are true, and since 8 and 3 are co-prime, we have that p